Hello, can you see my screen?
Yes, sir.
Okay.
Good afternoon, everyone. It gives me immense pleasure to extend to you a very warm welcome on behalf of Sagar Institute of Science, Technology and Engineering, Sistek E. Rathiwad, who has clubbed all of us for the 2 days international conclave on Industry 4.0, digital transformation and smart manufacturing technologies, jointly organized by Department of Mechanical Engineering, UIT RGPV Bhopal, and Department of Mechanical Engineering, Sistek E. Rathiwad, Bhopal. I, Dheeraj Kumar Singh, Assistant Professor from Department of Mechanical Engineering, Sistek Rathiwad, welcome you all. Encouragement, enthusiasm, excellence is one of the major aspects of the institution, with an objective of encouraging the spirit of research and innovations as a humble beginning towards empowerment of our society through advances in technology to create a better tomorrow. New technologies are introducing every day that will radically transform the future of the industries. The aim of this conclave is to share the recent development in the field of manufacturing, engineering among UGPG students and to explore and discuss on various aspects of smart manufacturing technologies. Now, I would like to request Professor and Head Department of Mechanical Engineering Professor Kshitij Bodh to share his words of wisdom with us.
Good afternoon, all. I welcome Mr. Ajay Holey, Manager Advanced Manufacturing Technology, John Deere. Sir, thank you very much for accepting our invitation out of your busy schedule. As you have told, it's 4:30 over there, so it's tough for us to wake up at 4:30, and you are giving your time. So, sir, thank you very much for that. And I'm very much confident with this session. Definitely, our student will learn the deep inside of Industry 4.0 because Mr. Hole is working on the same line. So again, thank you very much, sir, for accepting our invitation. Thank you.
Thank you.
Thank you so much, sir, for your kind words. Before inviting today's expert of the session, Mr. Ajay Hole, sir, Manager, Advanced Manufacturing Technologies, John Deere, USA, let me give you a brief introduction of him. Sir has completed his Master of Technology in Manufacturing Management from BITS Pilani. He has completed his Master of Business Administration from Amravati University and Bachelor of Engineering in Mechanical Engineering from Nagpur University. He is having total experience of 20 years in manufacturing engineering, operations, and digital manufacturing. Working with John Deere for about 15 years, handling various responsibilities, including expat at John Deere Finland, manufacturing systems deployment lead, smart connected factory implementation lead, manager advanced operations, in current role as Manager Advanced Manufacturing Technologies, leading team with work towards Industry 4.0 technology deployment across John Deere, which includes robotics, XR technology, IoT, CVML, manufacturing data platform, and analytics. He has also served some of the reputed companies like Nipuna Services Limited as senior engineer, Bosch Limited as engineer, Swapnil Auto Engineering Private Limited as engineer. He is having licenses and certifications in mixed model line design trainer, Leonardo Group Americas, lean manufacturing, BMGI India. He has also received honors and awards in the field of Knowledge Leader of the Year issued by John Deere India January 2020, Digital Manufacturing Competency Lead issued by John Deere Technology Center India June 2019, and Enterprise Innovation Award issued by Deere and Company June 2018. Now, I would like to request Mr. Ajay Hole sir to share his knowledge on the topic Industry 4.0 for manufacturing excellence. Respected sir.
Thank you. Thank you for the kind introduction. Again, just a small correction. I'm currently here in USA just for a few weeks. I'm located in Pune, in India. Okay. So my topic is Industry 4.2 technologies for manufacturing excellence. And again, so what do you see this, right? Probably most of us might have seen this in a different forms. Um, it's the floor mill, right, which used to be there uh, old days in every household, right? Then it got converted, and again it got converted, and finally, like this is how we can see in the today's scenario, right? Similarly, like how the every process uh, goes through transformation, industry is also going through the transformation, and that's what this industrial revolution has been happening uh, through different centuries. uh, the first industrial revolution was around mechanization, right? Like it was leveraging the steam engines. The invention of steam engine came into the picture, and then in the 20th century, that happened in 18th century, and like after almost 2 centuries, uh, the concept of the line production lines, mass production, came into the picture, right? The Ford Motor Company, they started making the car in assembly line, and that's what is the revolution happened in the manufacturing, wherein from batch production type of scenario moved to a mass production kind of a scenario, leveraging the assembly lines. Few years later, the third industrial revolution started, wherein use of electronics and also some of the use of computers got into the manufacturing, right? The industrial robots came into the picture. The automation, the factory automation uh, was the major drive, and that has completely revolutionized the industry. The work that used to happen manually used to be performed with the help of robots, or even with some of the automations within the machines or within uh, the industry. So that probably pretty quickly that happened, like it's in uh, like 1970 or so. But this revolution, the fourth revolution, is around the internet, right? We have been, the internet came into the picture. Uh, we are seeing the how the internet has impacted all of us, right? And this internet came into the industry as well. The digital and the physical environment came closer, and that's how the industry 4.0 is today. Obviously, when this industrial revolution are happening, it is bringing in that, like why that industrial revolution is happening is actually to take care of the complexity, the level of complexities that were earlier probably could have been managed with those kind of technologies or the given set of processes that were there, but definitely not possible in today's scenario, wherein we have uh, probably requirement to handle any type of customer demands, any type of configurations. So number of optionalities that want to provide to our customers, and that has increased the complexity. And the solution for that will be Industry 4.0, the different technologies that it is bringing in. Again, if we see, like, the industrial revolutions are uh, is there, okay, and the changes that used to happen earlier are no more taking those many days or years, right? If you see, the telephones were in existence almost for 75 years, right? uh, Web almost for 7 years. Like, Facebook is there, like to reach those 100 million customers, like how many uh, years or days it has taken, you can see that. So reach of the technology is so quick, so fast, and the technology can be obsolete without, like, understanding that, okay, whether it has reached to uh, a level or not, right? There is rapid change that is coming, and probably number of users want to, like, use that, okay, that has been increasing. So you can see how that reach has been going to the customers for these, some of the products. Now, if we see, like, many of today's factories probably are prior to Industrial 4.0 deployment, we do have like sequenced assembly lines or production lines, uh, wherein there is a leverage of the robots. Okay, we are able to, let's say, produce the output that is desired from that. Okay, but definitely the complexity that is getting added, uh, as well as uh, we are not able to enhance the efficiency unless there are some of the drastic changes that we need to do. And that's how, when we see the factory of future, okay, uh, it needs to be very highly flexible, highly integrated with manufacturing systems, and that will be what uh, enable us to meet the demand that are there from the customers. Okay, uh, like today, you can customize any of your, let's say, computers. Okay, similarly, there are opportunities for customizing, let's say, cars. There are opportunities for customizing each and every product that we manufacture. And uh, the today's production line scenarios probably are not going to give you that ability. And definitely, the Industry 4.0 adoption will be needed for making those fully flexible, highly integrated manufacturing setups. So let's talk about the building blocks of Industry 4.0. Again, uh, there are different layers there. Okay, on the right hand side, if you see, uh, the ecosystem has the connectivity, the transport, and the security. Then there is that uh, on-prem or edge or cloud or data management. Okay, so this is the second layer. So giving a detail of that, what exactly it is. And again, Industry 4.0 is again industrial internet of things, is basically adoption of that, and the adjusting uh, capability or the technologies. So there are different uh, things that are there within the factories, which include PLC, robots, CNC, different types of drives, different types of sensors, right? Different types of walls, different types of hardware that is available on the shop floor. Okay, so these are nothing but those edge devices. Okay, like the devices, we call them the things in the Internet of Things world. These are the things that are there which are generating information. Okay. Now you need to have something which is the communication protocol between these things. Okay, like so that you can between these things, and you call it server, you call it cloud. Okay, like the data management basically, where exactly you would like to manage that data. On-prem are nothing but the server locally within that environment. uh, you might have heard about the cloud as well, right? AWS, right? Azure. So those are nothing but where you have some kind of a shared space wherein you will be storing some of that data. And again, they are like it is providing opportunity to uh, save that data on the cloud, which is a shared environment, at a cheaper cost instead of maintaining the infrastructure on your own within your premises. Again, based on different types of requirements, based on different types of use cases, that needs to be defined whether that is a strategy that needs to be adopted based on the use cases, whether it is on the prem, on the edge is nothing but within the premise itself, very close to the premise itself, and the cloud is nothing but at a remote location. So that's how different types of uh, the real-time controls, dynamic configuration, reconfigurations, the process data acquisition, human and machine interface, the HMIs, right? Online programmings, that is enabled through those different types of communications. So, which includes OPC UA, okay? There are REST APIs, there is TCP, there are MQTT, right? MQTT brokers. So, all these different types of communications are leveraged, okay, to connect these edge devices with the data platform, okay, wherein you can acquire that data, okay, and then you actually uh, collect that data. You can use that for data analytics, you can use that for data visualization, you can use that for deployment. So all different types of monitorings, remote debugging, most of those things can be possible once you have that data. Obviously, there are different types of applications, okay, which leverages this data and which help in enhancing the existing processes, which help in identifying the bottlenecks, which helps in identifying proactively. It is more of a proactive. Okay, you can build your data models, data analytics, which will predict some of the failures. So that's how the overall the building block of industry 4.0 is different layers that are there within the industry 4.0. One of the important aspect is the data security, and that's how that encrypted data comes into the picture. Cyber security is a very important pillar in adopting industry 4.0 technologies. So what are the potential implications of adopting industry 4.0? Okay, uh, we will have more and more robotic operations. There will be predictive maintenance, no more preventive maintenance. So it's not based on the reaction, but it is more uh, like predicting something. Okay. Uh, so additive manufacturing, obviously, this technology is being there for quite some time now, but now how it is going to be mainstreamed in the manufacturing processes itself, how probably it is going to replace some of the machining operations. uh, Machine as a service will come into the picture. It is not probably a dedicated machining centers to produce a specific type of part, but with the help of this uh, the additive machines, which can probably on a like click of a button, you can interchange between any type of part. The machine as a service can come into the picture. Like no in future probably no one has the factories won't require to own their own machines. It can be a service offered, like how we are getting the service offered for uh, Uber or Ola, right? The cars are available as service. AI, ML, artificial intelligence, machine learning, deep learning are going to drive the quality control. Probably no more quality inspectors required. Everything will be driven through these technologies. Production line near real time simulations are going to come into the picture. Today, probably we are kind of uh, doing the simulation uh, part of the planning, and again the actual implementation and the simulation, like always there are differences today. Obviously it has significantly enhanced how we are implementing the things, but still in future, when everything is going to be connected together, it will be possible to get the feedback, real time feedback within the simulation models, and which will enable to visualize what is going to be the impact because of the current scenarios that are happening within the environment. Smart supply management networks will be there. If we talk about the visibility, supply chain visibility, okay, that will be possible with the help of smart supply management networks. Again, so there are different types of products that has been evolved. You can see example of Philips lighting, right? So Philips has been making lights for quite some time now. But if you are aware, there are smart homes, right? Smart facilities wherein um, the user controlled, like with the help of your mobile phone application, you are controlling the lights as well, and that's what uh, like the lighting itself has transformed. Okay, those are becoming smart, right? Then Medtronic, okay, this has implemented digital blood glucose meter, okay, which connects wirelessly and monitoring your glucose, blood glucose, displaying that, providing even the alerts, right? So that has transformed how historically these things used to happen. There is another Ralph Lauren uh, t-shirts are there, which can stream the data. So today we probably have different types of bands or smart watches, which gives this information. But the clothing itself, the apparel itself, has uh, the ability. Okay, because you don't need to wear anything additional. You already get that with the help of the t-shirt that you will be wearing. Okay, so which includes like calories burned, the distance covered, all that. Then Babolat, this is another uh, like device with the racket, tennis racket, which came into with the help with the sensors, allowing tracking uh, the the balls, okay, the speeds, the spin, so that uh, there can be enhancement, that information data can be available for the players so that they can improve their games. So these are some of the revolutionary products that uh, are invented to adopt the technological development that is happening in recent part, and that is what probably is required in the industry as well. When we are uh, working from the manufacturing processes standpoint, how do we revolutionize those manufacturing processes? So talking about the industry 4.0 technology, again, um, I will not uh, go through all of this, but some of the important technologies probably we will cover. And I will share some of my experiences as well. So, obviously, Internet of Things, big data analytics, cloud computing, cyber security, right? Horizontal, vertical integrations, robotics, augmented reality, additive manufacturing, and simulation. It has been there quite some time now. So these are different technologies which enable the industry 4.0. Uh, again, uh, here we have IoT, but when we talk about uh, manufacturing, okay, uh, we don't uh, like say IoT there, we call it as industrial Internet of Things. But before that, let's understand like nowadays we tend to say everything like IoT, right? But what is IoT and what isn't IoT? Let's understand that. So IoT actually enable uh, it is enabling the infrastructure. Okay, it is a mean of connecting objects, one object with the other objects, or the machines to machine connectivity. So different types of, it is a mean through which you can connect the machines. It is actually extension of internet, uh, which include like earlier. So just think of how the internet has came into our life. Okay, a long time back, it used to be on a PC, okay, where you had a LAN connection, and through that LAN connection, you used to have low bandwidth internet. You could do some work there, right? Uh, Probably very few things that could be possible during that time. Uh, it has grown further, right? The internet is available. Uh, Internet is available with some of like the devices as well, right? The tablets or phones, right? That is how internet available on tablets, internet available on cell phones. Then internet also available with some of our machines, right? uh, you might have seen um, some of the cars, they have been advertising internet inside, right? So those equipments and machines that we use, probably they are coming up with the internet, right? And you can probably control them with the help of application. So the next step is more how it is getting inside the factory, okay, getting on each and every objects within the factory, and that is what the industrial internet of thing is. Now, why, like what it is going to enable is, it is enable sensing, it is going to enable decisions, and also it is going to take actions based on the data that is getting collected. So what is not uh, internet of things? So just an application or a service is not internet of things. uh, it's not a separate network of objects. Okay, it is the connection between the objects. It is not just getting the data from the sensors. Okay, uh, probably just getting the data from the sensor is a one-way communication. Okay, here what we are talking about is two-way communication. You get the data, you like uh, do the data analytics on that, and you predict something, you communicate back, you give the feedback. That's what the internet of thing is. And it is not mainly about database coordination as well. Okay, so that's what is IoT and what is not IoT. So again, I'm also talking about industrial internet of things, which is applicable for the industry. um, we are talking about uh, like two things here. One is the consumer. When we talk about the consumer, consumer is nothing but the customer, right? We use our cell phones, we have our home appliances, we have our smart watches. Okay, these are the consumer facing um, things. And uh, when the IoT is applied for that, it is nothing but the internet of things which is focused on the consumer. And that's how the focus of the IoT is more on commercial or consumer convenience side. uh, like it focuses on smart device development. Okay, it focuses on security risk measures. Okay, but it is again very much centric to the utility, the application that consumer is having, using, and it is human centric. Whereas when we talk about internet of things, it is for the high stake industries like manufacturing, healthcare, oil and gas. Development focus is always for the sophisticated machines that are there in the factories, as well as those processes which are there. There need robust security and risk measures. Okay, otherwise, uh, like probably we will not lose much if someone just hack your uh, smartphone, right? Probably your CCTV camera. Yeah, it may have some implications as well, but still, uh, it is going to impact only one human. But in case of uh, the same, uh, within the industry, it is going to completely disrupt or impact uh, the industry if there is no robust security and risk measurement measures in place. Again, it is going to be also kind of a service model which is machine centric, whereas in the internet of things it is human centric. So when we talk about, you probably are engineering students and you might be having some management lessons as well, and you might have seen the hierarchy of needs for individual, right? So these are nothing but the how there are different needs for the internet of things as well. So from the self existence standpoint, okay, when we need a bread and butter, right? um, the foundational, the clothing and shelter, all those. Similarly, the power, connectivity, climate and value is what is needed from the self existence standpoint, coupled with the security. Okay, which includes secure chip, encrypted, authenticated application, and our devices. Then there is a self expression. Okay, self expression in the sense wherein we want to communicate these things that are there, okay, which are like which are in existence, let's say. From the self existence standpoint, they need to be there. You need to connect them, you need to the collect the data, right? And that's what the self expression needs are, which includes interface communication, networking, as well as transaction logs and diagnostics. After this, your self actualization comes into the picture, wherein you start developing the smart applications based on the data that has been collected, okay, based on these things that we have here, where we do analytics, logics are learned, and the the behaviors are predicted. And that's how the hierarchy of internet of things needs uh, can be understood. Okay. Now getting into how the market is moving within this area, within the internet of things. Edge computing, this has been utilized in manufacturing heavily, within the manufacturing. And for what? Okay. uh, it has been leveraged. Okay. It has been used for the quality data. Majority of the time it is used for the production data, machine data. Okay. You can see these are the three major areas where the edge computing has been leveraged. On the right hand side, you can see the IoT use cases for the manufacturing. Majority of the IoT use cases are in the remote engineering, energy efficiency, asset reliability. Okay. So remote monitoring is something definitely has come uh, a great value during the pandemic time, where there were challenges with respect to physically being present, uh, ability to kind of hand over the knowledge, ability to solve the problems by uh, getting by making available within the physical environment, right? And uh, that's what, like, remote monitoring is one of the top most use case within the IoT. So if we look at the adoption of the IoT, uh, so uh, it has been a journey for many organizations. Many of them think that, okay, they like they probably are going to get this uh, within next 12 months. Okay. But again, finding the budgets, uh, there are, like, many who are saying that, okay, it is the future, but right now we probably are not able to invest into that. And some of them don't expect them to invest within the next 12 months. So, but there is majority of the industry, okay, 27% of them, which are having focus for IoT adoption, okay, or Industry 4.0 adoption, because it is the, like, for the survival, definitely you need to adopt that change. So what are those challenges that industries are investing, okay, um, for IoT? The major challenge is from the business case standpoint. Obviously you are not going to uh, invest on something which is not going to benefit you. uh, like, as this has been, like, new to everyone, uh, most of the time, okay, they are not able to uh, figure out, okay, what exact benefit it is going to provide me, what is the business case. Okay. Then comes the funding. Okay. Then comes the standards. What are the standards that I should be adopting? Okay. So these are some of the challenges wherein right now the industry is investing. So let's talk about the digital thread or digital twin. Okay. um, we know that, okay, there is a real world, there is a digital world. Okay, and there are different value chains in between, right? uh, like the product goes through different life cycle, right? That the product life cycle includes the product design, production planning, products engineering, actual manufacturing or production, and then service. Now, how to establish that thread, okay, or uh, connect between each of these processes, okay? um, if these uh, value chains are connected with each other seamlessly, okay, something changing in the design is seamlessly getting adopted for production planning, for production engineering, for production and service, then it is the digital thread that we will be able to establish. Okay, and a digital twin is going to be kind of a replica of the physical world in the digital environment, where you are actually able to, because of you have that digital thread established between the value chains, uh, you will be able to understand, okay, the real time scenario, what is happening on the real uh, product into the digital replica of it. And not only you will be able to get to know uh, the real status of the real world in the digital world, you will be also able to control, okay, from the digital environment, the physical environment. So that's the the completely integrated digitized value chain, which is very important from the replicating a digital twin. uh, Second big technology is robotics, and again, earlier it was industrial robots, okay. In the third industrial revolutions, robots came into the picture, and they have been everywhere, many places, mainly in the fabrications, let's say, for weldings, for paint. But in addition to that, okay, this market is not only restricted for the welding or painting now. The application has gone further. The material handling, the assembly line, okay, are the areas where the robots are getting used. Collaborative robots are coming uh, in use, right? I don't know if you have heard about collaborative robots. Have you heard about the autonomous mobile robots, which are completely autonomous uh, equipments moving material from one place to other place? Probably you might have seen the AWS Amazon warehouse, right? No human being there, all the material automatically getting transferred from one place to the another place based on uh, the specific order that customer is uh, like what placing, right? So that's how it is revolutionizing the industry by adopting uh, the robots in multiple areas, right? And this is just uh, uh, like you can understand like how that growth is happening within the robotics industry. AI, MLDL, okay, artificial intelligence, machine learning, deep learning, these are also very important uh, technologies from the Industry 4.0, industrial Internet of Things adoption standpoint, which are going to give that uh, so prescriptive predictive analytics, right? So that will come through adoption of artificial intelligence. Again, when we talk about artificial intelligence, it is machine learning, right, which will help predict. uh, you do the predictive analytics or you do the deep learning. Okay. Again, text to speech, speech to text, we have seen that in Outlook itself. You can you don't need to type. You probably like today, probably on the cell phones we do have, right? We don't need to type. The kids today, they don't type at all. You just say something, it automatically search or type. uh, Computer vision and the machine learning, CVML. Okay, so that is again getting leveraged for mistake proofing. It used to be machine vision earlier, but it uh, coupled with machine learning, it is more and more reliable now. Okay, which is uh, controlling your processes. Uh, no manual visual inspections needed, right? And obviously, uh, for the planning and optimization, uh, like it is definitely going to be an enabler. uh, Even enhancing our machines, robots, all this uh, like are making our machines intelligent. Okay, so that's how the this technology also going to be playing a key role here. Then is the XR. Okay, um, the extended reality. So there are different types of reality, right? Virtual reality. What is virtual reality? uh, you can see. Okay, the fully within a fully enclosed synthetic experience, we can get the experience of that real world. And nowadays, those headsets are available probably for few hundred rupees, where you can put your camera and you can play those VR. YouTube has the VR videos as well, right? You get that 3D experience of the environment. uh, from the industry standpoint, these are some of the things are enabler. From the the operator standpoint, for or the customer standpoint, right? uh, we have been, like, this has been getting leveraged for some of the uh, like real estate, right? Understanding how the future home will look like, right? Augmented reality, again, which is augmenting uh, the things in the real world. Okay, something which we probably uh, expect. Okay, uh, like something which is going to be in future, but we would like to see that how it is going to augment within the current environment. uh, the MR is kind of a merged reality, right? Which is interaction and manipulation of both physical as well as virtual reality. Microsoft HoloLens, I don't know if you have heard about that. Those are some of the technologies which are going to enable this mixed reality, okay, or merged reality. So, uh, all of these are also going to have a big impact within the manufacturing. The way the interaction between the humans are happening within the industry, that is completely going to change. So, for example, uh, these type of smart glasses will be there with the operators. Okay, someone who is preparing the parts for the assembly, they don't need to one by one find the tags and identify the parts and pick and place. Probably those smart glasses are going to provide them the information related to, okay, where that part is located, even navigate them uh, to the part, and even help them identify, okay, this is the right part that they have picked. So this is how like it is going to be used for the material handling. On the other side, for the operators working on the assembly lines, they will be able to get their work instructions, okay, how they need to perform their jobs with the help of the augmented reality or mixed reality. This is how the manufacturing excellence will be achieved with the help of these different technologies. I think if we see uh, uh, where this extended reality has been getting leveraged right now, okay, so far manufacturing is not up to the mark. Mainly it has been leveraged in education, but definitely there is a huge scope within the manufacturing to expand the leverage of this technology. Okay, so that's, I think, what will bring us a smart connected manufacturing which will deliver the excellence. Okay, what will be there, it is kind of a manufacturing plant which will have the monitoring of production flow like real time, okay, in a real time, uh, eliminating the waste, unnecessary the inventories, in process inventories, right? That's how it will be. It will manage the equipment remotely using the temperature limits, the other setting that are there. It will also conserve the energy, it will reduce the cost. Okay, uh, it will also enable implement condition based maintenance of the equipments, okay, and avoid the downtime because of the failure of the machines. Okay, it will aggregate all the data from the customers, all the different sources, suppliers, and help identify what probably was an issue that customer has faced, the operator is aware of, so that those the issues are not repeated again. Okay, um, again, it's kind of a visibility of the whereabout of the material, real time visibility, so that the planning is more effective. Today's scenario wherein you need to call, okay, where is the material, okay, and probably the guy told you, tell you that it is here, but may not be there. Okay, so but with the help of technology you are actually seeing the whereabout of that and planning the things accordingly. So this is how the manufacturing excellence can be achieved with the help of uh, the different technologies that are offered by Industry 4.0. And that's it. I think that was my last slide. I hope we are on time here.
Uh,
Yeah.
Thank you so much, sir. Sir, our students have asked one of the questions, so
Hmm.
I would like to ask them. Can
Okay.
I ask questions?
Yeah, go ahead.
Okay, sure, sir. Sir, one of the student had asked, what is the difference between Industry 4.0 and the Internet of Things?
Yeah. So Industry 4.0 is uh, a broader term, probably. So this complete industrial revolution that is happening it can be called as Industry 4.0. Whereas Internet of Thing is a technology wherein you are connecting the edge devices, collecting the data, okay, and probably doing a lot of the things with the help of that. So uh, uh, Industry 4.0 is a broader, I will say, terminology, and Internet of Thing is a sub element of that.
Right, right, sir. Sir, one student has asked, sir, can you elaborate cyber physical systems?
Yes. So cyber physical system, cyber is nothing but uh, digital. Okay. Physical, the real time is a physical. Cyber physical system is nothing but the interaction between the digital world and the physical world. Digital is nothing but we are using the CAD, right? Most of you are mechanical engineers as well, right? So you are using pro engineering or um, uh, like Creo or uh, other different types of uh, systems for designing, creating the 3D models of the products. uh, how that 3D model is connected with the physical model of the same thing is actually cyber physical. Yeah, correct.
Right, sir. Thank you so much, sir. Now, I would like to request Professor C.K. Pardi, Department of Mechanical Engineering, for vote of thanks. Pardi, sir, please unmute your mic.
Thank you very much, Mr. Ajay, for delivering the excellent and knowledgeable session with us. I know, in spite of your busy schedule, you accept our invitation to share the knowledge on this conclave on the topic Industry 4.0. I know that presently you are in US and it is early morning there. So once again, thank you to cooperate with us that you accept that you will deliver your session from there itself at the morning. It has been our pleasure to host this 2 days international conclave on Industry 4.0, that is the digital transformation and smart manufacturing technology. Though this is the new topic for our students, but we have been fortunate to have some of the eminent persons from the industries who are working in the field of manufacturing and adopting the new technologies in this area. And definitely, Mr. Ajay has given deep insight about how the industrial IoT, how the artificial intelligence, how machine learning can be incorporated in the manufacturing to make the production better. And definitely, the main outcome of this conclave will be the awareness to our student about this new technologies, and they will think about the new skill set to adopt the challenges coming up during the placement for uh, to get the place in the industries. So if the students aware about the things like industrial IoTs, artificial intelligence, machine learning, definitely they can do excel during their uh, during their placement activities. As a convener of this conclave on behalf of the Institute, it's my great pleasure to express a deep appreciation for the support and encouragement provided by each individual and institution. I am very much thankful to UIT RGPV for sponsoring this conclave and accepting to conduct this event jointly. My special thanks to co-convener Dr. AC Tiwari to accept invitation to organize this event with them. I put my heartfelt gratitude to all the speakers, Dr. Yogiraj Pardi from Sajlar, Mr. Nitin Rangdale from Fog Marshal Pune, Mr. Rohit Tiwari from Wills Group, and Mr. Ajay from John Deere Company. To plan and organize such event, the driving force is required, and I must thank our principal, Dr. Manish Billore, our director, Dr. Jyoti Deshmukh, for always inspiring and encouraging to conduct such type of events. I thanks to HOD Mr. Chitiz Igbud, co-convener Mr. Sanju Gupta, and other faculty members of Mechanical Department, uh, Dheeraj Singh, for supporting to conduct this event successfully. I am also thankful to all the UG and PG students who participate in this conclave to make it a great successful event. Once again, I thank to everyone whose contribution has made this conclave a successful event. Thank you, everyone. Thanks to all. Once again, thanks to Mr. Ajay. I think
Thank
he
you
left.
everyone for joining us. Thank
ये सर
you.
लेफ्ट हो गए सर.
Thank you, Dheeraj sir.
ठीक से एंड कर दूं. अजय सर लेफ्ट हो गए
Yes, sir.
सर.